Let's take a look at this integration by parts problem. If you look at this integral, it's the integral of x to the fifth times ln x dx. It's a product, so one method of dealing with this integral is by integration by parts, which is a method that breaks up products. The first thing you need to do with integration by parts is to essentially look at the two pieces of the integrand and figure out which part you want to call u and which part you want to call dv. So we have u and dv. And remember that u is the thing that you're going to differentiate and dv is the thing that you're going to integrate. And if you look at the two parts, you don't really want to integrate the natural log, so this would actually be the best u, and x to the fifth dx would be dv. So u is ln x and dv is x to the fifth dx. And so we need to calculate du and v, so we can use the integration by parts formula. Du, the derivative of log x, is 1 over x, and then we have a dx. And if dv is x to the fifth, v is its integral, which is x to the 6 over 6. And so now we can use the integration by parts formula. U dv equals uv minus integral of v du. And integral of u dv is our original integral. That's x to the fifth ln x dx. So let's write that down. X to the fifth ln x dx. That's equal to uv, and u was ln x, that's what we decided, times v is x to the 6 over 6. And I'm running out of room here, so I'll write minus integral of v du down here. V is x to the 6 over 6. Du, that, remember, that was 1 over x dx. And so we can simplify that second integral, because x to the 6 over x is x to the fifth. So this is x to the fifth over 6 dx. And the antiderivative of x to the fifth over 6 is x to the 6 over 36, using the power rule for integrals. And let's remember the plus c. And so this ln x times x to the 6 over 6 minus x to the 6 over 36 plus c is the antiderivative for x to the fifth times ln x. Over here in the beginning, we made the choice of u equals ln x and dv equals x to the fifth dx. If we had did the opposite thing, it may be tempting because you go, oh, x to the fifth, I can turn that into 5x to the fourth if I took its derivative. That's not really advisable, since you really don't want to try to take the integral of the natural log, since it makes it much more complicated. And we do want the second integral to be, not more complicated than the first one.